So in our last video, we left off sort of talking about if you have the inverse t function on your calculator or not program. So again, just to double check, if you start with second bars, it'll bring up, if you have it or not, this inverse t. So we will use that in our next example. Again, if you don't have this, if you're in my course, you can see the video linked on how to program it, or you can also Google inverse t like 83 video, and it'll pop up, a couple, and you can go through and you can program this into your calculator. So let's take a look at our first example. It says find the value of t of c, so your critical value, which is now going to be a t distribution, that would be used for a 95% confidence interval if n is equal to 2. So the way we sort of think about this is very similar to the critical value for a z distribution. So my 95%, right, that's basically all of this piece here. Right, 95%. And so we need to figure out what's in the tail. So 1 minus 0.95, right, gives us 0.05, divided by 2, so 0.025, and I'll shade that in pink, right? That's what's in my tails. So I tend to find just the negative value, and then I write it as a positive, because I understand that this, right, this negative t of c critical value and positive t of c critical value, they are the same. It's just one's negative, one's positive. So if I were to write this, my inverse t, I'd be 0.025, right, area to the left, and then my degrees of freedom. So degrees of freedom is n minus 1. So in this case, I take 24 minus 1, right, it's going to give me 23. So 23 would be what I plug into my calculator, and I'll write eventually my critical value. So again, I'll start over here. So you hit second and bars. You're going to arrow down to minus number 4. It's going to ask you the area, so 0.025. Degrees of freedom is 23. And we'll paste that and hit enter. And so if I look at this, right, so negative 2.07, it doesn't really say where to round, so round accordingly. But usually if it's just asking for a critical value, we want to write it as a positive. So understanding that, right, this answer is producing this value here, but in general, 2.07 is going to be my critical value. Okay. So now it says, finally, let's do a complete example of a confidence interval for one population mean when your population standard deviation is unknown. So we're going to look at example 2. So it says a study on the amount of television watched per day last year by the average person was conducted. There were 30 people included in the survey. The sample mean was 4.760 hours, and the sample standard deviation was 2.297 hours. Find and interpret a 90% confidence interval for the mean amount of television watched per day last year by the average person. Okay, so I like to always, again, write out what we have. So 30 people, so n is 30. Sample mean, right, x bar is 4.760. The sample standard deviation was 2.297, and our confidence interval, right, is 0.90. So I notice I have my sample standard deviation, right, and I'll highlight this, right, which is S. So I'm thinking t distribution, and I notice, right, I have a sample size of 30, so we're good to, assume that the sample is normal. So I can start by finding my, right, critical value for t. So again, if I draw my curve, right now it's 90%. This is 90%, right? So 1 minus 0.9 is 0.1 divided by 2, so 0.05 is sort of what my little tails are, right? So 0.05. So I'm going to find, right, this value here, which will be negative, but when I write it, I will just write it all as positive. So I can do second bars, go down to the fourth one here, 0.05. Degrees of freedom, so I didn't find out degrees of freedom. Degrees of freedom is n minus 1. So in this case, my degrees of freedom would be 29, since I have 30 people in at the beginning. So 29. I'll paste this. So again, I like to write it as a positive value, just in my general formula. So I'm going to say 1.7 when I round. So 1.7, you could add the 0 in or not. Okay, so I'll write this up, 1.70. Because remember, the goal is we're finding this, x bar plus or minus, right, the margin of error, or just the error. So my margin of error is T of C times S, so right here, divided by the square root of n. So I have T of C is 1.7 times 2.297 divided by the square root of 30, right? That'll tell me my error. So I enter this into my calculator, 1.7 times 2.297 divided by the square root of 30. Oops, I don't need, let me delete that. I don't need that extra parentheses. If I arrow out of the root, then I do. Okay, so my error, I'm going to keep a couple decimal places. So 0.713 would be my margin of error. So if I take, right, x bar minus, right, plus or minus the margin of error, I'd end up with, right, my mean was 4.760 minus 0.713 less than mu less than 4.760 plus 0.713. And so remember, we're creating this confidence interval, minus 0.713. So 4.047. And the last one will add that, 4.760 plus 0.713. And I have 5.473. All right, so that is my confidence interval. And now usually the last thing, again, we do is just interpret it. So we can say with 90% confidence, we can say that the mean amount of television watched per day last year by the average person was between 4.047 and 5.473 hours. Right? Okay. So again, we usually just sort of interpret what did we actually find. Okay. So that is my sort of full confidence interval, how I find it sort of piece by piece. Now, again, as with the last two sections, your calculator actually sort of does all of this for you, so you don't have to go through and do each of these pieces. So if you want to know how we can do this just with our calculator, I'll write it above example 2. So we're going to go to our stat button. So we'll hit stat. We'll arrow over to tests. So tests. And if you can sort of see what we have here, hopefully you can see we're going to do the t interval. So this is number 8 on my calculator. So hit that there. We have the stats. So we'll arrow down, we'll put the mean. So 4.760. Standard deviation, 2.297. Sample size is 30, right? And the confidence interval is 0.9, and we will calculate that. So, right, these hopefully should match. And if you notice, right, 4.047, 5.473, right, is what we found. So again, just an alternative way that you can find your confidence interval. And as long as you don't really need little pieces of the problem, for your homework, maybe it wants the margin of error, maybe it wants the critical value or something like that. But if it just wants the confidence interval, As long as you have all this information at the very beginning that we had, you can go through it and really just go from this step here to our final answer and then our interpretation. All right, so our last question in this section, again, is just, it gives us information sort of in a different manner, and we have to think about what would that mean. So it says express the confidence interval, so 114 to 175.8, in the form of x bar plus or minus the margin of error. So I'm going to draw an interval. So I have, right, so 114 to 175.8, right? This is my confidence interval. And so what it's asking for is we want the sample mean and we want the margin of error. So if you recall, the sample mean, right, should be right in the middle, right, of this interval. And so what I want to do is if I have two numbers and I want to find, right, the middle point, we are going to average them together. So we would take 114 plus 175.8, right? Find out what the sum is and divide that by 2. And that should be, right, the mean or the average of that interval. So 144.9, right? That should be what x bar is. And if you recall, right, plus or minus, so from the endpoint to the sample mean, right, this is minus the error. And from the sample mean to the upper endpoint, we have plus the error. So if I find the difference between the endpoint and the sample mean, then I should be able to determine what the error is. So you could find the error by 175.8 minus 144.9, right? Or vice versa, 144.9 minus 114 should give you the same value. 0.8 minus 144.9. And that leaves me with 30.9, okay, for my error. So if I wanted to write this in the form, we said I'll write it again, x bar was 144.9. So in this form, x bar plus or minus the margin of error, we would write it as 144.9 plus or minus 30.9. And that would be how we could go from here's a confidence interval to find the sample mean and the margin of error.